everyone. My name's Beth, and I'm here today with Neeraj from my team. We both work at IBM, and we're in the Node runtime team. And what we'd like to talk to you about today is Cloud Native Node.js. So a Cloud Native application is just an application that's designed to leverage cloud capabilities. First, a bit of background as to why Node is so good in the cloud, and also for microservices. So I/O speed, very important when you're deploying in a cloud, because most of the time you're pinging a REST API or something like that, parsing a JSON object and getting it back. So the speed in which you can parse that is perfect. So in JavaScript, this is an Express app. We get 1,150. The higher the number, the better normally with I/O speed. And then we're comparing this to a Spring Boot app, which only gets 897. So immediately, Node's a good choice because you're getting faster I/O speed. Then there's startup time. So when you're deploying inside something like Kubernetes or Docker, you really want things to scale up and scale down very quickly. So the amount of time it takes for your app to start is important. With Express, you're getting less than a second. For a Spring Boot, you're getting about 14 seconds. So when you want to add a new node, you've got to wait 14 seconds before it can actually start handling requests. And then you have memory. So when you deploy to a cloud, you often pay per your memory usage. So you can either have small, medium, or large, or maybe even a monetary value. So the less memory you use while executing your app, the better. So when you compare that with Java or a Spring Boot app, 23 meg versus 422 meg. So again, why Node is so great for microservices and clouds. So there's been a few surveys of cloud developers recently, and we looked at them to try and find out what are people doing with their apps in the cloud. So a lot of people, 100% are saying, we're deploying our app in the cloud, but only 38% say they're using cloud services. So that's, instead of using a cloud service database, they're actually just getting their database, putting it in a VM and deploying it. And only 12% are saying they're writing fully cloud native apps. So native apps are leveraging all of those cloud functions and things like that. The Node.js Foundation also did a survey, and again, similar kind of feedback. 79% say cloud hosted, 48% say Docker, so that's quite good. A lot of people are saying Docker's the way to go, the way to deploy your apps. But only 12% are using Kubernetes, so only 12% are actually managing those Docker containers, scaling them up and down when they need to. So the Cloud Native Computing Foundation have a set of projects which they believe all link to creating cloud native apps. You have Cloud Foundry, Kubernetes for managing your Docker containers, Prometheus and Open Tracing for monitoring and tracing, and Helm and Docker. What we've done at IBM, we started this initiative, but it's completely open source, is we've announced a project called Cloud Native JS. And the idea is that it provides you a set of resources where you can go if you're a Node developer, and you can pull them in and start writing cloud native apps. So this is just our website. We've gone for a few redesigns, but it's all open source, so if you'd like to help us out, it'd be great. And what it's comprised of is a few sections. So we have module insights, which is all about how you choose modules that are good for use inside your cloud application. We have Docker, where we provide some Docker template files. We have Kubernetes, and in there, we provide some sample Helm charts for you to use to deploy inside Kubernetes. We have a health checking app, Open Tracing, and Prometheus. We have some modules that you can pull in so you can easily connect to those services. So the first is module insights. So what we've started doing here is listing top modules. For now, we've just taken like the top 40 or a selection of 40, but we aim to grow it. And we're trying to gather some data so you have somewhere to go to work out what should I be using in my app. So if you're just building a prototype, it's probably not a problem just to go to NPM, find a suitable module, and have some fun hacking it together, and it's fine. But when we're looking at IBM from enterprise customers and enterprise deployments, we need to look at these modules and work out, are they supported? Are they well maintained? Do they run on all of our architectures? Because at IBM, you can choose to deploy on Power or Z. Does the module actually work on those platforms? So this is all collated data. The green and red tiles, that just mean what we're doing there is each module provides its test suite on GitHub, and we pull in that module's test suite, run it, and report back whether it passes or fails its own test suite. And we do that across a variety of architectures, so you can drop down and be like, oh, does Express work on Power or what have you. We also give license information. If you're working at an enterprise, you probably have to take a look at the licenses and make sure there's no GPL or what have you in your proprietary app. The idea is just so you have somewhere to go to try and get a bit more information than what you get on NPM or something like that. Again, it's all open source. We're planning to expand it as well. One of the columns there, you'll see stability. What we started looking at recently is long-term support of modules. So a lot of modules don't actually have LTS policies like Node does. And what they are people will agree Express 4.x, that will be supported for 2 years. So you know that as a developer using Express, you won't have to take in any breaking changes for at least 2 years. A lot of modules don't do this. So you could be stuck in a position where you have to either accept a breaking change or not get the latest security fixes. So a lot of modules have started to sign up to these. Happy has their own one and things like that. It's just a way of making sure that the module you're using will continue. Well, you're not going to be broken by them updating whenever. Loopback's another example. So they've agreed to support the 2.x release line for the lifetime of Node 6. And then we have Docker. So what we're doing here is, as part of Cloud Native JS, we provide sample Docker files. So these files, at first, they just assume you've got an Express app running on port 3000, but that's all configurable. And what we've done is provided this so you can just pull it into your app, do a Docker build, and then you've got your Node application packaged up. We've ordered this in a specific way because when you do Docker builds, what it actually does is it does it layer by layer. So step 1 will be from Node 8. So that pulls in the Node 8 Docker image. And then we do some operating system updates. And then we copy in your package JSON and do the npm install. So we install production so we don't get dev dependencies. The reason we do the install in the Docker file itself is because you might be developing on Mac. And if you do your npm install on Mac and you have native code, it might not work inside a Ubuntu Linux Docker container. So you do it inside the app. And then you copy your app in. So what I said about ordering, chances are you're rarely going to change the Node 8 image. So that will be cached. You're rarely going to change, OS updates won't often change, so that will also be cached. So as you work through, because it's all cached and only rebuilding at the point something changes, you're actually saving time doing your Docker builds. That's why the app copying into the container is at the end. And then it just starts your app. But actually, what the Node 8 image supplied by the Node Foundation is actually 716 meg, because it uses, I can't remember off the top of my head, Alpine? No, it's Debian. It's a Debian image. So it's quite full-fledged. It's got all of the, I think it's got Node.js and Python inside it, because that's what you need for compiling native modules. But Docker actually provides something called multi-stage builds. So we've actually provided a template if you'd like to use those. And what it essentially does is step 1 is produce a full-fledged container that can do your build. So it can install your modules, handle all of that. And then it builds a much slimmer container, a very lightweight container, without the Python or Node.js or anything like that. So this is the multi-stage build just goes through, copies everything from the container you first started with into the second one. And as a result, you end up with a much lighter image. So the first one was about 700 meg. This one's about 200 meg. And obviously, the smaller your image, the quicker it is to build and transport. So that's fine. So you can package your application up, put it in a Docker container and deploy it. But often with high availability and scaling, what you want to do is you want to have multiple of them. So at that point, you kind of want to go into Kubernetes, where you can scale up and down. And at this point, I'll pass over to Neeraj.
Thank you for introducing the Cloud Native JS.io. I believe you've got the background on why we believe Node is such an ideal platform for building things and deploying them to the cloud. What we're trying to do with this initiative at the moment is try and provide as many resources as we can and help people on board and adopt as many of these cloud native computing foundation technologies as we can. The next one that we'll go from what we've covered so far is deploying to Kubernetes. Once you have a Docker app, what we're trying to do is we're providing a set of templates. Along with that, there are two key YAML files, chart.yaml and values.yaml inside the Helm. By the way, people who are not familiar with Helm, Helm is a packaging tool which helps you deploy an application into Kubernetes. So you can configure and tell Kubernetes how it is supposed to manage your application, how many instances do you want, how you want it to be scaling up and down, and all of that. And what we've provided are what we believe is a good standard to start with, and you can always tweak them around as you want. If I look at chart.yaml, mainly it covers information about your application itself. So what version you're using, a description, name of the application, and things like that. So you can just provide any meta information about the app. There are lots of other things that you can provide, but these are the bare minimum to get going on. The next is values.yaml, and essentially all of these values feed into the templates that are provided alongside, but you just edit the values file and then you've got all your configuration in one place. If I call out few specific things here, there's obviously the repository, which is the place from where you want to fetch your Docker image. It could be a local image that you've built up, or it could be something that you've pushed to Docker Hub or your enterprise Docker repo. Then we've got CPU and memory. So what kind of CPU and memory you want to be allocated to this instance of the application. And you've got how many instances of this application do you want. So we've obviously set minimum 1, maximum 2, where you could do 5 and 10 or whatever values suit appropriate for your application in terms of scaling them up and down. So when you deploy, it'll start with 1 in this case, and it'll go maximum up to 2. One more thing I wanted to call out here is the target utilization. I've put the CPU and memory values here, and those are the values that will determine when it should actually scale up and then scale down based on the upper and lower limits that I've put. And all of these could be tweaked. Again, we don't believe all applications are going to use exactly this, but it's a good place to get going. And then once you're familiar with it, you can tweak it to make it best suit your application. In terms of how do we use the assets that we've got, so if you go into the chart node server directory and do helm install and give it a name, node server is the name of the application in this instance, and point it to current directory where the chart.yaml and the values.yaml were, then that's all you need to do. I made an assumption here that you've got a Kubernetes environment running on your laptop or whichever environment you're pointing it to. But that's pretty standard. You can do it with a Docker on a Mac or anything like that. And as I said, as an example, if this was to start with, let's say 5, then it'll start with that, and then it could scale up based on whether memory and resources are used. Moving on to health check. Now that we've got an application running inside Kubernetes, we can scale it up and down, but we're not really still using all the power that Kubernetes can provide. It's just we're using it for scaling. So what we need to do is try and see if we can leverage some of the built-in capabilities a bit more and assist the environment or the platform to work better with us. So as an example, you've got 2 Express apps deployed on Kubernetes, and you would have Kubernetes environment act like a load balancer and routing requests to both the applications. What we could do is have a specific endpoint ready, which tells Kubernetes whether I'm ready to receive the requests or not. So that's basically telling you from the time it's deployed, is your application ready? Some of the applications might have to connect to databases, read some other configuration files, do some other initial setup. So you can do all of that, and during that time, as long as you return a non-OK value on this ready endpoint, Kubernetes is not going to send requests to your instance in a way. And once it's ready, it'll start sending the request over that. The other one is health, which is indicating Kubernetes when do we want the application to be restarted. So as an example, if you are trying to do something and you encounter issues and you want to signal the environment itself to say restart, there's something gone wrong and I don't think we can recover, then you can use that health endpoint. As an example, if this was being deployed in Kubernetes and one of the applications started returning non-zero values, then the environment will basically send a SIGTERM signal to the application. It'll give us about 30 seconds before it sends a SIG kill, and then it'll try and restart the app itself. When the app starts, it should start coming up with ready and health. Obviously, there should have been 2 stages there to say ready first, and then it becomes ready OK. And then it starts routing the request to the other app as well. To do this, we provided a node module under the Cloud Native JS initiative. And all you need to do is add that one line, which is the Health Connect module. And once you've added that module, you can basically register specific endpoints. So you've got app.use ready and app.use health, and then we've provided the health check object that we've created using that. The other thing you can do if you use this module is you can have your own listeners, or you can do your own stuff as a promise when these checks are executed. So if you look at line 3 there, we've created a promise, and that promise basically we are passing that back to the ready object, which is used in the ready check. So every time the /ready endpoint is hit, it will basically execute that promise, and you can do whatever you want to do to understand whether you're really ready or not. And you can do similar things, and you can have as many of those endpoints as you want. Moving on to tracing and distributed tracing specifically, because we are moving to a world where all the apps are split into small microservices and deployed and tied together to achieve and create a function. This is just a sample app that I have just created here. Assume there's a request coming from the browser, it goes to the load balancer. The load balancer routes the request to the backend, which is serving the web interface. And that calls up another microservices, which is fulfilling the orders, which uses a MongoDB database. But to do the order, I might need to check the inventory, which might be using a separate database. I mean, this is just a hypothetical application. But you can see the point that if the request is served and it is taking, let's say, 20 seconds to serve this request back, then how do I know where the problem is? Which one of these steps is taking longer than expected, and how do I go about identifying and then trying to see if I can fix the problem? And this is where distributed tracing comes in. What we've provided here is a module called App Metrics Zipkin, Zipkin being an implementation of the Open Tracing specification. All you need to do is add that one line in your application, and that module basically starts injecting some header values, which allow this distributed tracing to be worked out. So essentially, it generates a new token on every request and then passes it on as it goes from one microservice to another. And then you can use the Zipkin user interface. This is a screenshot from the Zipkin web UI, which gives you a full stack trace of which services called at what time, when we started, when we finished, how the call went from one service to another. And the bars indicate how long it took, essentially. So you can start looking at, in my entire application in the mesh, which one is taking longer and what's going on. Another thing that you get along with that is a visual representation of which microservice uses which one and what endpoints it's been calling. And that might be very useful when you're trying to re-architect one page to understand what are the external interfaces and things like that. Moving on to Prometheus monitoring. Again, Prometheus is a cloud native computing foundation project, and what we're doing there is adding a third endpoint called /metrics. What Prometheus does is basically it'll start returning some values on that metrics endpoint and start aggregating those values over time. What we've done is we've provided a particular module called AppMetrics Prometheus. Again, AppMetrics is a collector. It's an open source module that collects information from your Node module or Node project, and like CPU, resource utilization, blah, blah, blah. And then we are exposing that in a specific format that Prometheus understands here, essentially. So we are manipulating the format of the metrics that we are getting from AppMetrics and presenting it to Prometheus. Kubernetes already knows about /metrics endpoint, so it basically hits that endpoint every 30 seconds, every 10 seconds, whatever interval you configure, and then uses those. I mean, this itself isn't very usable and consumable, but what you can do is Prometheus has its own graphing capability, but they are fairly limited. Most people, how they use it is they install Grafana on top of it, and then you can create graphs like this for your application. Again, this is a sample. You can choose whatever things you're interested in and drag and drop particular metrics and create a graph over time. So when there's a problem, you can figure out, oh, at this point, this resource utilization peaked out, so I need to go and look at this and go that way. Prometheus can also be integrated very well with alerting systems. So you can start and have some alerting mechanism to say when the resource utilization goes over 90% or whatever, then you want an alert to be triggered. And these are just the basic things that I said, but there is a full-fledged tutorial which takes you step by step on what to do, where to get the resources, what commands to run, how do you use them in a basic Hello World Express app, essentially, at the Cloud Native JS org on GitHub. And basically, if you follow the instructions, you will be able to create an Express app and add health, add Kubernetes, deploy, monitor, all of that. So if you want to get started on any of that, then please follow this. By no means this is everything we want to do, and this is not just these 5 things aren't going to make your application completely cloud native, but this is a start. And we've started this initiative in July, so it's not been very long since we've done this. But if you want to participate, this is completely open source. Look at things, raise issues if you find something that doesn't work. Submit PRs if you want to fix something, or find us some Slack and tweet, and just join in the fun, I hope. Thank you. If there are any questions, you can do them at the break time.